Let tau denote the curve y is equal to yx, which is in the first quadrant, and let the point 1, 0 lie on it. Let the tangent to this curve at a point P intersect the y-axis. So this is the tangent to the curve, and it intersects the curve at P. Now if PYP, this is YP. Now if PYP has length 1 for each point P on tau, then which of the following options is or are correct? Okay. So in this question we've been given that 1, 0 lies on this tangent. Sorry, it lies on the curve. And now we know that the equation of the tangent would look something like this, right? So let's substitute y as yp. Now yp minus y1 is equal to minus mx1. So from here we get yp is equal to mx1 plus y1. Now we've been given the distance between yp and p as 1. So let's put it in the formula. From here we get 1 is equal to x1 square plus m square x1 square. Now when we write m as dy by dx, we get 1 is equal to x square into 1 plus dy by dx whole square, right? So from here we get the value of dy by dx as plus minus root 1 minus x square divided by x. Alright. When we integrate this equation, we get the value of I. So in this value, let's substitute x as sine theta and dx as cos theta d theta. On substituting the values and integrating, we will get that this is the final equation. Alright. Now as given in the question is that y1 is equal to 0, as 1, 0 is a term that is a point that lies on the curve. So let's substitute the value here. Now we get 0 is equal to this. From here we get that c is equal to 0. So from here we can see that option 2 is correct. Now in option 4 we've been given that xy dash plus root 1 minus x square is equal to 0. So let's check if this is correct. So as you've just calculated recently, y dash is equal to 1 minus x square divided by x, which gets cancelled out, which is equal to plus minus. So from here we get that it's equal to 0. Therefore this term is also correct. So the answers are B and D.